Thank you. I hope you can hear me well. Okay. First of all, thank you for having me here. It's always a pleasure. I always like being at Kamailio World. It's one of the really nicest events I know. Thanks to Daniel for that. I have a few topics. It's actually, I have more than one topic that I'm going to cover today. And of course, the initial topic will be what's actually the status on IMS and what's happening in the IMS modules. And then we're going to look at some very specific topics, like the HSS, which is finally open source, like looking at IPsec, why this is important and what this actually means to Kamailio and IMS. And then last but not least, we want to look at some non-Kamailio related issues, which is actually the handset issue. Okay, let's start with the status update. First of all, I have to admit that the last year was a little bit, I was a little bit frustrated from time to time. And the reason is actually quite simple, because we found on the market several commercial IMS solutions, which are in fact based on Kamailio, which is somehow quite annoying, because as you know, I spent a lot of time and money and effort on making IMS possible on Kamailio. But unfortunately for me, it's hard to prove. I know I have several people who told me, well, look at this, and this is probably Kamailio as well. And I'm like, okay, yes, really, really bad. The bad thing is actually, for me, it's hard to prove that it's really based on Kamailio, because none of the vendors would sell me their IMS core, and even if they would, I would not want to buy it. So based on that, there's no really way for me, at least at the moment, to make them open source or make them declare their sources. That's really, really annoying for me. On the other hand, it proves one important thing. And that's a thing that really, in a way, also makes me happy. Because it really, really proves that Kamailio IMS works. And it's not only me saying over and over again, IMS is great, and we need IMS, and we want to do IMS, and we can really use IMS on Kamailio, but it really proves that others see this as well. Okay. After being a little bit angry on competition, I hope you understand, you might see that a lot of changes that are happening in the IMS stuff of Kamailio are happening under the hood. And we have, from a technical perspective, in the last year, we've done quite a lot of integrations with different networks, with different components, and as a result of this, we actually added SCTP support for the diameter stack, and that's actually because a lot of PCRFs and a lot of other network equipment make SCTP mandatory. And since we've been integrating, we had to align the RX interface, sorry for the acronym, with the specifications of the 3GPP. And it's actually funny. This RX interface is actually responsible for doing quality of service. And in the past, we've been working with Nokia, Siemens, with Ericsson, and with quite a few others, and they were all happy with our implementation. Then we had to integrate with a small cell vendor, and oops, our RX implementation didn't work. And it was like, yeah, but we've tested it with so many others, and what should be wrong with what we're doing? And they said, well, okay, look at the following spec. You should send it this and this way. And we were like, yeah, right. In the spec, according to the spec, you're right, but the others treat it a different way. But OK, now it works with all of them, which is great. Yeah, and I have to mention quite a lot of other smaller improvements. OK, the next topic, which is actually a little bit a bigger topic, and if you were at Kamailio World last year, you might remember that I spoke about this last year already. But let's have a look back. Actually, as probably as so many with Kamailio and open source, we originally used the HSS from the Fraunhofer Institute, which is nice, stable, but of course it's not the fastest solution. It works somehow. Later, we decided, OK, well, it doesn't really, it doesn't have enough performance, especially when we were targeting some higher subscriber numbers. So we had to implement our own one, which was based on JBoss, MobiSense, JDiameter, and that was already 3 times faster. But unfortunately, like everyone in my company and everyone I know, except for my wife, don't tell her, it's Java, and no one in my company does Java, and nobody likes Java. So it was always a little bit, yeah, we've got something that works, but if you need customization, if you need to modify anything, can someone else do it? And since it was implemented rather quickly, in a couple of weeks, it had quite a lot of to-dos and really ugly hacks. So even though I'm a big fan of open source, we never really made that open source, and we never will. So last year, I presented our diameter server, which is actually doing a rather simple thing. It actually just takes a diameter message, converts it into JSON, and then you can do in Kamailio script whatever you want with that diameter message. So that's really straightforward. And what we did is actually put this diameter message into a RabbitMQ. And then on the back end, we have 1, 2, several worker processes who can actually create a response based on the diameter request. It's actually rather straightforward, and we used, of course, for the diameter part, Kamailio, now even with HTTP, and for the worker part, PHP. PHP, probably most people think, well, OK, that's a tool for web programming or something like that, but for us, in this use case, it did a marvelous job, and it still does. We use it quite a lot, and compared to the previous JBoss solution, I have to admit, it was heavily, extremely faster compared to the previous version. This is a little bit more detailed overview of our HSS. And of course, since it always depends on the level of integration you do with existing systems. So we've created a pretty straightforward REST API, which allows us to modify values in a database. But on the other hand, we've got several services where maybe a REST API isn't that necessary. On top of that, we've created a management portal. And that management portal, for some cases, talks directly to the database, like service profiles and maybe some rate cards, stuff like that. And for user provisioning, uses our REST API. Then it's all stored in the database, and we've got the worker process accessing the database, talking to the RabbitMQ, to the message broker, forwarding it back to the diameter server using the standard diameter interfaces of Kamailio. Works great. It's really a nice piece of software. And due to the flexibility of Kamailio and the other stuff, you can actually create a lot of more things with this piece of software. I think, for example, by the end of the year, maybe next 2 or 3 months, we might add a S6A interface, which will allow our HSS to do the full authentication on the mobile network, and a few other things. And last but not least, finally, it's on GitHub. Due to the topics I mentioned on the first slide, I was always a little bit hesitating. Well, another lot of work spent on different stuff. But yeah, in the end, we decided then we put it on GitHub because, yeah, we want more people to use it and we want more people to try it out. Okay, the next thing I'm going to cover is IPsec. Who's a little bit aware of IPsec? Okay. The reason why we're going for IPsec is simple. We want to implement voice over Wi-Fi. Even though on some topics the standards is not really clear, like there are some, if you look at the specs from the 3GPP on voice over Wi-Fi, you will find, yeah, you should use IPsec, you should this and that. In the end, it says, or an alternative secure way of making your communication. But anyhow, doing IPsec is the way to go. Why? Has anyone used voice over Wi-Fi? Yes, okay. Why do you want to use voice over Wi-Fi? Okay, for me as a subscriber, it's relatively easy because I've got my phone and I want, from me as a user, I have exactly the same user experience on my phone if I'm on Wi-Fi or if I'm on 4G. You get the same services. You get all kinds of messages, SMS, voice calling, you get your number presented, everything. But instead of using LTE, you can use Wi-Fi. And one of the reasons why, of course, some people may say, well, okay, well, we've got great 4G coverage. And I know James Bodie will hate me for that, but sometimes, whoops. Sometimes indoor coverage is not that good. If you go to the lobby here, and if you're depending a little bit on the network, on the corner where you stand, you might notice that you don't have any 4G coverage anymore. So if you allow Wi-Fi calling on the handset, then you can extend that coverage of your mobile phone to other new areas. Using in-house coverage, maybe in the cellar of your house, maybe whatever. Especially it's useful for me, personally, when I'm roaming abroad, which I do quite a lot. And so I can use actually the Wi-Fi in the hotel to make local calls at home. My mother is a perfect user. She's a very happy user of voice over Wi-Fi because she lives in the countryside where there's hardly any mobile network coverage outside the house, and in the house, forget it. So finally, using voice over Wi-Fi technology, I can call her even when she's at home on her mobile, which is an improvement, I would say. The technology behind this is, yeah, I have to use another acronym for this again. It's the EPDG, the Evolved Packet Data Gateway, which is some sort of IPsec gateway. So what you will see is that a voice over Wi-Fi capable phone will contact the proxy CSCF, will thereby exchange some key parameters. And with this key parameters that are provided in the zip register message, the EPDG can then create the IPsec tunnel to the phone and thereby establish a secure connection. so far, so much for the theory. All of this is done in a separate module, in the IMS IPsec PCSCF module, which actually utilizes the IPsec Linux kernel implementation. Yeah, there are a few things that I would love to have, but I have to admit that we won't see that, at least initially. And that is the seamless handover between LTE and Wi-Fi, because for this, we need to connect the ePDG or the IPsec stuff with the P gateway of the LTE network, because the technology for doing the handover is actually that the phone, regardless of the access technology, regardless if it's Wi-Fi, CDMA, or LTE, will get the same IP address, so it can basically continue the call. Now I've been talking quite a lot about IPsec, and I have to admit that none of this would have possible, because for me personally, I didn't do it. I always wanted to do it, but we've got a great open source community. So Svitomir, I would give an applause for him because he implemented the IPsec stuff, and we're not there yet, but I guess we're pretty close. Thank you.
So he's here, right? Hands up, or?
Yeah, he should be here, yes.
There. Thank you.
If you want to get more details on the IPsec stuff, ask him, not me. Okay. Now, my last topic for today is the handset issue. I've covered this basically a little bit on Monday, because if you've been working with IMS, if you've been working with VoLTE, then of course, if you know the right people at mobile operators or at Samsung or similar, you might get an engineering firmware from Samsung which will allow you to do voice over LTE and voice over Wi-Fi on basically any network. Of course, that's not really mass market, because I really like my Chinese phone, and we don't have, for that we don't get the engineering firmware. I tried to contact them, but failed with the marketing department. And usually, if you're running a VoLTE network, then you have to cope with the networks, with the devices the users already have. So that's a big challenge. Yeah, and especially if you want to get onto the handsets, one thing is you have to talk to each and every vendor. Maybe not with each and every vendor, because, for example, if I take my Gigaset handsets, you basically have to talk to MediaTek, because they're providing the chipsets, but on Samsung, because they're building the chipsets as well, you have to talk to Samsung. And of course, this takes quite a lot of time. And especially if you talk to Samsung, then yeah, they will tell you it's going to take 2 years at least. If you talk to Gigaset for the handsets, then they will just forward your request to MediaTek, and again, that takes time. And you have to talk to every single one of them, and that's really annoying. My personal opinion is that voice over LTE should be enabled by default. And that's the way it should be nowadays. I think that having a default profile which does circuit switch fallback, it's backwards. It's not the way it should be these days. But that's the way it is at the moment. This is a big issue for every VoLTE deployment. And yeah, and this is, in quite a few cases, a showstopper. There has been an initiative by the GSMA, by the Association of Mobile of the mobile industry, which is a good attempt. It started last year, and the goal is basically to make VoLTE available to any open market handset. I'm not talking about the Samsung you get from your T-Mobile store or anything like that, because there you might get a special firmware for T-Mobile anyway. But I'm talking if you go to the local electronic superstore and you buy just an LTE-capable handset. It's great, but it has some catches. It hasn't been widely adapted yet. If you get onto the device settings database of the GSMA, you get support on the iPhone 6 and newer versions, of course. That's a great step forward. And talking about MediaTek, I mentioned that before, it will also get you on newer MediaTek devices. But again, sometimes the device manufacturers are lazy, even though they might add this to the newer versions, the newer devices. It really sometimes they stop providing updates, so at the moment you end up on 5 to 10% of the Android devices. If you look at the worldwide smartphone OS market share, then okay, of course we've got the 13% iPhones, where we can enable VoLTE using the GSM database, but then we've got like 85% Android phones, and the others, we ignore them basically. So even if you take those 85% and you say, okay, from those 85%, I can reach maybe 10%, it still leaves a huge gap. In order to circumvent this, we did, I would say, a lot of research and development on this. And actually, the SIM card that every phone, that every operator has, is the key to solving that issue. Because you can actually provision, technically speaking, it's you're storing the hash value of the certificate of your app on the SIM card, and that gives your app carrier privileges. And with those carrier privileges, you can actually override the default settings of the handset. So that adds up for, I would say, another 70 to 80% of the handsets, which really is a great thing, which really makes VoLTE mass possible. And the funny thing about this is actually, I used the term black magic quite a lot on Monday, but again, it's 3 pages on the Google Android docs who exactly describes this feature, but for us, so far we just provisioned the IMSI and some cryptographic key variables on the SIM card and maybe some other basic stuff. We never really looked how to implement, how to push a certificate on the SIM card. And even when we spoke to various SIM card vendors, they said, no. Only one company, Sysmocom here in Berlin, they really provided us great help with implementing this. Okay. That's it from my side. Questions?
Thank you. So, questions, yeah.
Yeah, I was just wondering, how do you test your environment if you don't own a mobile network? How do you actually solve that one?
Okay, that one is rather simple. When I was starting with voice LTE, IMS, some years ago, initially I was looking for a small network cell which I could deploy in my lab. The first offers I got was like 30,000, 40,000 euros, and I thought, maybe not at the moment. Just a few, I think a year later, I came across a small French company, Amarisoft, and they provided me the EPC, eNodeB, MME, all this mobile network stuff, on a software basis, so I just needed a radio head and a proper PC. And that brought the price of my own small 4G network cell to something like 8,000–9,000 euros. And I'm using that for testing the stuff. And of course, I'm doing, of course, since we're working a lot with operators, I'm using their networks as well. I can show you the cell. I have it outside. I haven't connected it this morning, but I have it here.
Question about your SIM hack. If I understood it correctly, it basically would enable LTE support, voice over LTE on the mobile phone.
Yeah.
But that's far away from a working device. It just means it will try. So is that intended to enable you to test devices, or is it the idea just to enable them so they can work with the network? And
it's really the idea that they can work with the network. It's really
that's optimistic.
If you look at the specs from the Android documentation, you find like 100 options, which includes emergency calling. If you're doing emergency calling on IMS, if you want to have voice over Wi-Fi, if you want to enable, disable settings. It really gives you the power on controlling the handset and how the handset behaves. And the goal is really to make VoLTE work on as many POS devices as possible.
Okay, and last question from James, because again, they have a demo table outside. Please approach Carsten, he can show more.
Well, it's not so much a question as a kind of a request. If anybody really is interested in this area and you want to find more, come and find Carsten, come and find me, because for the last 2 years, I've been focused at building open source mobile network cores. We have access to SIM cards, multi-IMSI, multi-crypto SIM cards. We have small cells, considerably cheaper than the Amari soft one that Carsten's operating with. And if you want to find out more and come and play, make yourself known, and we'll see what we can do to help you.
Thank you, James. Thank you, Carsten, once again for everything.